So if you go to all lessons, let's say we're in Google Classroom, right? And we want to go to previous lessons, maybe not the one from the day before, but definitely the ones that have been graded, that you see the grades in PowerSchool. If you were to click on them, you would see something like this. It says view accuracy. When you click on it, you're able to see the lesson again, which a lot of you have been asking, and you're able to see also if you got it right, if you got the question right or wrong, and also the feedback. So this is just an explanation that we provide why your question, why your answer is right, why your answer is wrong. But this is basically an explanation of why this is the right answer, why this is the wrong, why this answer is the wrong answer. And it's an important skill that we need to start having, is going back to old work. I know you do it a lot in other classes when you get feedback maybe from Mr. Vison or Mr. Valentine, but it's also important in science because we're filling out an assignment every day, and just fill out an assignment and say, whoop, I hope I got every question right, bye bye. That's sure, do it if you're that confident, but also have the skill to go back, see your work, see if you got it right, see if you got it wrong, see what topics you need to improve, see what things are not clear yet, see what things you need to ask during the check-in or during an email or during a comment. So really important, and that's for the lesson and exit tickets. You can do that. Just click individually which one are you curious, but just wait at least a day so we are able to grade it, put the grades in PowerSchool, and apply the feedback. So another thing, this is an exit ticket. You click on view accuracy, and you're able to see what questions you got right, what questions you got wrong, and the explanation of why that's the right answer. So really important. Start, go over your, when you have time. Obviously, this is, you make your own schedule, but definitely go back to the all lessons, all exercises, all practices, and see whether you got it right or wrong. All right, that's all I wanted to say about that. I'm probably gonna mention it tomorrow. I'm gonna mention it a million times again, but that's something that you can do. All right, so we're still talking about variation. And variation, just remember, when we say variation, we don't mention what comes before it, but we usually mention genetic variation. All right, so when we say variation, we imply genetic variation. That's just, we are humans. We can make shortcuts just in the way we speak or the way we write. Just remember, there's always a genetic before, even if you don't see it in there. There's always a genetic variation. And because it's generic variation, we put a question on the exit ticket that is due today that asks, is generic variation only for phenotypes or genotypes? And that's a question a lot of people, the answers that I've been seeing, they tend to get it one-sided. So they either say, oh, variation is always only in the genotype, or variation is only in the genotype. But what we know, if we have been paying attention for the last weeks, we know that what we see in a person, how they look, how an animal looks on the outside, their phenotype, has a lot to do with their genotype, with whatever their genes or their alleles are in their DNA. So when we ask, is variation for phenotypes or genotypes, we should be able to answer and be confident when we answer in saying, hey, variation, sure, they look different, but also we know they also, in their genes, they are different as well. So it's not only their phenotype that is different, but their genotype is different. We kind of go and look at the DNA for each animal or for every person in this classroom. But the evidence that we have, the observations that we have just looking at their faces and their bodies, that's enough evidence to say their DNA must be different. Their alleles must be different. That's something that we are able to infer, or we have evidence just looking at people's faces, and we say, hey, their genotype is different. We look at I don't know, a basketball game, and we see people of all sizes, and they have different skills, they have different behaviors. We cannot just go around the court and test or take a sample of everybody's DNA, but we know because they move differently, they look differently, that they must have different alleles and different DNA. So really big important thing to take note of: genotypes and phenotypes. Both of them contain variation in organisms that reproduce sexually. All right, so this is the lesson that is due today. It's just, again, we're reviewing and reviewing again until we have that exam, that test. Sometimes this week, we will review before that. And there's some more examples of generic variation in this lesson. We talk about some frogs. So as you can see, the frogs have and this is another thing I want to make clear. This group of frogs that we see here, I'm gonna make it a little bigger. There is a group of frogs in here, and because they look different, let's ignore the alleles for a second. If we were just to look at how they look, they're different colors. We could already say two things. We could already say, one, they must reproduce sexually. We know that they're not reproducing asexually because they look different from each other. And number two, they have different, not only phenotypes, but they have different genotypes. And there is a question that follows that asks, do you think their solar characteristics, aside from skin color, do you think they might be different in other characteristics? And the answer is up to you, but I'm just telling you, sexual variation not only involves one gene, not only involves one characteristic like skin color, it involves every single gene that you have in your body. So when we say humans have variation, we don't only say eye color, hair color, and that's it. We mention every single gene, every single one of the 20,000 genes in your body has different alleles that everybody has a different combination of. So if we're only talking about hair color and eye color, it will be very difficult to say that's variation because that's the only two things. Can you really say, oh, there's only two things that are different between you and me? That's something that is hard to say. We need to keep in mind that variation includes thousands and thousands of genes. Things that sometimes we're not even seeing another person. We see maybe their height is different, maybe how they look on the inside is different, maybe their systems, maybe the diseases that they have, and we don't really look at most of the time somebody has a disease that is inherited. We don't see it in the body, but we know that's a product of variation. All right, so there's another example in the lesson that is due today. It involves polar bears again. Polar bears are really cool. We need to protect them from extinction. And one of the key things to protect them from extinction is keeping their numbers large, right? So we're looking here, just very quick example of variation. There are some bears that are a little darker, and the bears that we are more familiar with are whiter, a little grayish, okay? And it's just another example how in this population, let's say this population is one big group of animals. Some of these animals will probably not survive. So this mom and this cub would probably not make it through the winter. They probably wouldn't be able to survive just because they don't have the camouflage to hide from their prey and hunt. So we know they're going to go extinct. But this group right here, this part of the population, is going to survive and pass on their gene. So the gene for white color, the allele for white color, is going to survive and is going to pass to the next generation. So to these kids and to the offspring of these cubs as well, they're going to survive. And that's one quick thing that I want to ask you. We have another example in here. Actually, let me, instead of just giving you the answer for this lesson, let me go to an example from an exam. So this is a question for the exam that you're going to take in less than 2 years, the science exam. And it's a question about a population that has two different colors for the same bug. So this is a ladybug. It comes in two different colors. They're the same species, the same group. They can reproduce with each other, but they just happen to be in two different colors. So you're going to notice in here that they ask you, they tell you 70% of the population, so 70% of the animals in this population have the light color, and 30% of them have the dark color. So same population, 70%, so most of them are clear, are light, and 30%, or the minority, are a little darker. And it gives you a little explanation before that. It says the habitat of this beetle population is a group of trees with light colored bark, so similar to the moths. And it says, based on the information provided, explain why the beetle population in this habitat contains a higher percentage of beetles with A. So the question is, and I'm going to ask one of you, why are most of them white instead of a little dark? Why most of them are light instead of dark? Based on what you know of variation, why most of them are white. And I'm gonna go to the chat, but before that, let me check something. All right, so let me ask, let's see who I haven't asked. let me ask Ikrabe. I haven't asked Ikrabe in a while, but Ikrabe, would you be able to answer that if you want to unmute yourself? Can you just give um an inference, just give me a hypothesis of why do you think most of the animals are this color instead of this color? So 70% are clear, 30% are dark. Why do you think most of them are this color instead of this color? If you were to answer this question in the exam. And you can mute yourself if you want to answer. If you want to decline, just decline. I guess another person. All right, so who else wants to answer? Just tell me in the chat who wants to answer. Just write answer, decline. Okay, no problem. Sure. Lisa Guzman was the first one to answer. So Alisa, can you unmute yourself and just give us an inference? So why do you think there are more of this instead of this?
I think there are more of the white ones instead of like the darker color ones, because maybe the white ones blend in more with the environment that they're in. So like the white ones are more safer than the darker ones.
Yep, that's a perfect answer. So in this question that you will be in the middle of the exam in 2 years in the classroom, and it says, based on the information provided, explain why the beetle population in this habitat contains a higher percentage of beetles with color A. You would answer that and you would get probably full points on that question, because you're giving two things. You're explaining why the environment is different and why the product of that environmental change, or why that difference in the environment is going to give us more of one than the other. So you guys will get full points on that question. And that's something similar we see in the example with the rabbits in today's lesson. So in today's lesson, it gives us a similar example, but in this case, it's something interesting. They give us a bar graph, which is a lot of you think is super obvious, but also it's a little difficult for some people. I understand. So in this question, it gives us two moments in time. 10 years ago, the population was mostly tan, so that means a little yellowish of rabbits. And then 10 years later, when the environment changed, the population was a different color. So most of them, if we were to just make it similar to the question we just did, that Elisa answered, most of them 10 years ago, most of them, we're gonna say maybe 60% were tan, and 10 years later, most of them were a different color. Now this is something that I want to make super clear. Do you think the size of the population changed? So let's say 10 years ago there were 1,000 rabbits, and 600 of them, let's say 60%, 600 of them were tan. Did the population get smaller? 1 second. Sorry, Terence, if you can mute yourself. I can hear your background. Muting yourself. All right. So, did the population become bigger or smaller? Did the number of rabbits increase? So, since if we had 1,000 rabbits 10 years ago, do we have less rabbits today? Do we have maybe 500 rabbits, just because we know some of them died? Since we're seeing here, the 10 rabbits didn't survive that much. Does it mean that we got less rabbits today than we had 10 years ago? No. The population always, and most of the time, actually stays the same. So the population is not going to increase or decrease that much, even though some of them die. And you know the answer why? Because even though some of them die, we know some of them did survive and made more rabbits. So population, if we were to ask in this week quiz, does the population change? Does the population number of animals or individuals change? No. The only thing that changed is what most of them are. So most of them, a biggest percentage of them were tan, and then it changed to most of them being gray color. So once again, the population, the number of animals doesn't change that much. The thing that changed is the distribution. How much are there from one characteristic versus the other? All right, so let me say it again. The population, the number of animals doesn't change that much. The thing that changed is how much of each characteristic there is. And if you were able to read the bar graphs, congrats, you were able to do an advanced skill that you require in math and science as well. So if we look at the bar that is higher, that means, look at the y-axis, more rabbits. Same in here. We look at this gray bar is taller. That means that we look at this y-axis and we see number of rabbits. The taller the bar is, the more rabbits we have. All right. So it's a very good skill to have reading this type of graphs. All right. So you look at the bottom for the characteristic, and you look on the side for what am I measuring? Am I measuring number of rabbits, number of animals, the height? So really useful skill to have. Be able to read these bar graphs, and that's a really important thing to do. All right. Let's see. Takeaways. Again, this is for the lesson that is due today. A population with variation survives because individual with useful adaptation survive even though others died. Again, the population didn't become bigger or smaller. The only thing that changed was the number of animals with one characteristic of the other. All right. So if some of these die, that means some of them need to survive to make up for it. And number two, the adaptation allele becomes more common because those individuals reproduce and pass on to the offspring. So adaptation means that these allele survive and was passed to the kids. So 10 years later, the kids of these parents, the next generation from these parents, acquired that allele, inherited that allele, and that's why we see more rabbits in this case. All right, the practice is something similar, is adaptations in the animal kingdom. Look closely to the video. There is another one, a reading on the rainforest. You're gonna notice that the lesson that is due today is a little longer than usual, and that's because we posted it on Thursday. So you have basically 4 days, if not more, to complete that activity. And the exit ticket as well, just some questions about adaptation. We have in here another question that we took from an exam, from 8th grade exam. So when you see this type of questions, you know that those questions are probably you're gonna see them again in 2 years or less than 2 years actually. So very good skill to have, just doing those answers and doing this type of exercises. So again, once again, the population didn't change, only the percentage of animals changed, all right? So the percentage of tan rabbits became smaller and the percentage of gray rabbits became higher. I wanna see, I'm gonna go back to the chat and just wanna see some questions that you guys have. Let me see if there is some spam Tuesday morning when it's due again. So yeah, the lesson is today. Again, the lesson is due today, but we don't say it's due at 4 p.m. anymore. You can do it a little later than that, but please don't do it like right before midnight. It just means that you have a couple extra hours to make it, but also be mindful of your time. You need to take care of yourself. Don't work until midnight. I read. All right. So anybody has any question about the topic? Yeah, the quizzes questions. So the quizzes questions that we did last week, you're able, two things. You're able either to go back to your quizzes profile and see the answers. So you're able to either see that. Tomorrow we'll have probably another quizzes. So you're either able to go back and check your answers in quizzes, or you can also go back to the exit ticket. The exit ticket last week from Tuesday, actually Wednesday, was almost the exact same questions from the quizzes. And you can expect that from exams as well. Usually we just use the same questions over and over. We just change some words, change the animal, change the characteristic, because that's what's really happening when we look at the, at our observations. All right. So again, Naomi and Leah were the winners for last week. Close to Aiden, Reina, Emily, Tyler. You know your score. Quizzes, guys. Quizzes is just practice. Quizzes is just a competition we make every week. Your grade is the exit ticket, your practice, and your lesson. So your grade are how well you do it, and if you completed the 3 of them. All right. So not only is filling out the answers, not you guys, I'm not singling anybody out, but a lot of people just write things that either are just words, or they might say words that they think are smart because they're related to the topic. So this tells me anything. This is just two words that sure they are vocabulary words, but that they don't mean much. So we grade not only you finish your activities, but how well you do. All right. So it's two things that measure how well you do in this class and what grade you're gonna get this year, and what grade the people from the high schools are gonna see when they look at your grades. Wait, do we have no quizzes? So Enrique, the quizzes are something we do during the check-ins. We do it to study, to practice, and also to compete with each other. But you get graded on your exit tickets, your practices, and your lessons. But if I was you, honestly, there is no reason why not to do the quizzes, because they're questions that we might use in the exit tickets or the quizzes. So, and you can see the answer right away. So there is no reason why you shouldn't do the quizzes. I like that website, to be honest. Anybody has any questions about the topic? I did it like 2 times. I can hear nothing. Yeah, is that true? Sorry. All right, anybody has any more questions? We have 5 minutes. Anything whatsoever that troubles you? All right, Raymond, that's not productive. You keep it to yourself, Raymond. Or you will, be kicked out. All right, but nice to meet you, Raymond. All right, so once again, variation is how different the genotype and phenotypes from one population is. So in case of humans, we have different phenotypes. Obviously, we look different from each other. So phenotype, right away, we know is different. And second, because the phenotype is different, we know they must have different DNA. They must have different alleles in their genes. All right, so not only different phenotype, but also different genotype. And the second thing we need to really make sure is that when we look at a population changing from one characteristic to the other, we know that it's not the number of rabbits that is changing. Like the population is not becoming less or more. It's not saying that, oh, half of the rabbits died. It's just saying that because some of them die and because some of them survive, the next generation is going to have a different percentage of every characteristic. Just like the question that Elisa answered, when we look at this question that she answered and she got a 100 in her test, 70% of the population is white and 30% of the population is dark. Maybe if we have an environment to change and the trees become dark, then the percentages are going to change. The percentages change, but the number of beetles in total is not going to change that much. All right, so percentages are going to change. How we look at it in the graph is going to change, but the population survives. The population is going to survive no matter what, as long as you have variation. All right. The reason some animals become extinct is not because the reason some animals become extinct is because you get rid of the variation. So we look at an example of Tasmanian devils a little, I think last week or 2 weeks ago, and they were becoming extinct because they were hunted so much that they didn't have enough variation. So when they got a disease, which was cancer, they died. Most of the devils started dying right away because they didn't have enough variation to survive. All of them were almost exactly the same, and all of them didn't have the immunity or the resistance for the cancer or diseases.